Alright, number 29. Here's a good one for us. Solve the system of equations graphically using a graphic calculator or by hand. So we have y equals 2x plus 1 and y equals negative 3x minus 4. Keeping in mind our y equals mx plus b. It tells us what the slope is and what our intercept is, our y-intercept. We'll graph them both starting off by hand. Okay, so the y-intercept for the top one, 2x plus 1, is 1. Good luck. Okay, there, I got it. Okay, and the slope is 2, which equals 2 over 1. So it's up to 1, 2, and over 1, right to there. Okay, so that's one of our lines. I'm not going to draw them in yet because I'm afraid to. Alright, the other one is y equals negative 3x minus 4. So let's go find minus 4. It's right here. Okay, and then the slope is a negative 3x, so negative 3 over 1. So let's go down 3. I think we'll change that to 3 over a negative 1 under the circumstances. So we'll go up 3. One, 2, 3, and they'll go back 1 right there to negative 1, negative 1. And we'll plot that. Okay, so now, so there's our first equation, 2x plus 1. There's our second equation, a negative 3x minus 4. I had a little difficulty doing that. That's the trouble with a touch screen. You know, touch screen, a big fat stylus. It's not very precision, but you can be much more precise if you did it on graph paper with a ruler. Alright, the other option is to use the graphing calculator, so let's do that. Again, with our graphing calculator, you'll go to that upper left-hand button, y equals, and push that, and then put in both of your equations. And then you push the upper right-hand button, graph, and you'll get the graph. And notice that our graphs are very similar. Not exactly the same, but the graphing calculator doesn't graph it exactly the same. Now, you're wondering, well, how can you tell where they intersect? Well, there's one more thing you can do, and that is you push second, that light blue button, well, on mine it's light blue, and then you push the one next to graph. It says calc, C-A-L-C. When you push calc, you'll get a little screen that looks like this. And see there's value, 0, minimum, maximum, intersect. There's a differential and an integral. You want to push 5 or bring the cursor down to intersect, because it's the intersection of those 2 points. So that's the intersection of those 2 lines. So, and then you'll push enter. You'll push enter like 3 more times until it says guess, and then push enter when you see guess, and that'll give you the intersection point, which will be, it'll say intersection x equals negative 1, y equals negative 1, and that's where they intersect. Even though your calculator's graph doesn't make it look exactly like that. However, it did calculate the correct spot, which is negative 1, negative 1. And that's where our 2 lines crossed that we did by hand. So the graphing calculator will tell you exactly where they intersect, while the graph it displays won't be quite as exact, especially if you try to do perpendicular lines or something on it. Let me show you. I had to take a picture, but there it is. that's what you'll see. You'll see the graph, and you'll also see at the bottom intersection x equals -1, y equals -1. So you can do it either with the graphing calculator or by hand. You draw the graph from the graphing calculator, but you might just want to go calculate and write down what the exact point the calculator says is. Okay, number 30. Solve the system of equations by using the substitution or elimination method and then show your work. So number 30, solve the system of equations by using the substitution or elimination method and show your work. So you got to show your work, otherwise I wouldn't know if you used substitution or the elimination method. You might think you guessed or did something peculiar that's not allowed. Alright, so substitution method, we'll take and we'll put 1 in terms of one of the variables, like y, and then substitute that in. That's like the way I did that Connecticut-Pennsylvania problem. I substitute, well, it was one of the methods I used. I substituted the Pennsylvania, Connecticut plus 14 in for Pennsylvania. You know, so I could have both with just, I could have just one variable. So that's what we do here. We try to find a way of eliminating one of the variables. Alright, so this equation right here, it has just it's 1y, so that'll be an easy one to do. So we'll go 2x plus y equals 5. Okay, I'm going to subtract a negative 2x from both sides. So that gives me y equals a negative 2x plus 5. Alright, so that, I'm going to substitute that. See, since this is y, let me change colors. Since this is y and this is y, I can, and there's supposed to be they're a system of equations, so that they're going to cross at one specific spot. I can substitute this in for that y. Alright, so let's do that. So we have 3x minus 2 times, and I'll put in the new y in here, negative 2x plus 5, and that equals 4. Notice, in this equation, that equals 4. I'm not talking about the other equation. See, so I substituted this part in, whoops, include the negative sign, I substituted it in for that y. Okay, so now I just have to solve this equation. So first I simplify by distributing. So we've got 3x minus negative 2 times the negative 2x is positive 4x, and negative 2 times positive 5 is a negative 10, and that equals 4. Now combine like terms. We have 7x minus 10 equals 4. Okay, I'm going to add 10 to both sides. And now I see, so my 10s cancel each other out, right? And I've got 7x equaling 4 plus 10, which is 14. And then I divide by 7. 7's cancel out. So x equals 14 over 7, or 2. So we know that x equals 2. Okay, so x equals 2. That's my x, but we still need to know what our y is, because we want to have a coordinate pair as the answer, right? So we've got our 2, but we need the y. So we'll stick it into either equation. It doesn't matter which one. So why don't we stick it into this one? We'll have our y equals negative 2 times, I'll put our new x in, 2 plus 5. Okay, so I just have to solve that. Negative 2 times 2 is a negative 4 plus 5, and a negative 4 plus 5 equals 1. So my y equals 1. Put the 1 in. So our ordered pair is 2, 1. Now we'll use the elimination method. Elimination, we're going to eliminate one of the x's by adding the two equations together, right on top of each other. So we'll copy them. 2x plus y equals 5. And we have 3x minus 2y equals 4. So now if I subtract the second one, 3x minus 2y equals 4, from the top one now, I'm still going to have two variables. So I've got to change them. Or if I add it, it's the same thing. I'm going to still have my two variables, my x and my y. I want to just have x, or I just want to have y. All right, so what I can do is I can multiply both sides of the top equation, 2x plus y equals 5. I can multiply both sides by 2. So let's do that. Multiply this one by 2, and I'll multiply this by 2. And I'm going to send it over here. So 2 times 2x gives me 4x, and 2 times y gives me 2y, and then on the other side 2 times 5 will give me 10. So now I have 4x plus 2y equals 10. Now I'm just going to write the other one right underneath just the same way, but minus 2y equals 4. Now notice, I'm not going to subtract them, I'm going to add them. Because when I add these two together, notice that these two will cancel themselves out if I add them together. So what I'm going to get 7x, add those together, these will give me 0. What's 0? And this will give me 14. Okay, so then, I don't know if you remember seeing this before, right? We have 7x equals 14. Divide both sides by 7. And this can cancel, and we get x equaling 2. Okay, so again we have 1/2 of our ordered pair. We've got to stick the 2 into one of the equations. In this case, this one's available over here, so I'm going to stick it into this. So 3 times 2 minus 2y equals 4. So this way we can find out what our y is. So we get 6 minus 2y equals 4. And let's add a negative 6 to both sides. And we get a negative 2y equals a negative 2. Let's divide by a negative 2. And we get y equals, change color again, 1. Negative 2 divided by negative 2 is 1. And there's our ordered pair. 2, 1. Same one we had from before. Notice. Same ordered pair. Simplify the expression. 8x to the 5th power times a negative 2x to the 2nd power. These, if you remember the rule, is that if you're multiplying two variables with exponents that are the same base, you can just add the exponents. But if you forget all this, there's about 6, 7 different little rules. If you forget the rules, it's good to remember that you can just factor the thing and multiply the numbers times the numbers and the variables times the variables. Let me show you. So we have we can factor out the 8. Say there's 8 times x times x times x times x times x, 1, 2, 3, 4, 5. and that is times negative 2, and that's times x times x. If you add up the x's, we have 1, 2, 3, 4, 5, 6, 7. 7 x's. So we have x to the 7th power. And then we multiply the two numbers, negative 2 times 8, and got negative 16. So there's your answer, negative 16 x to the 7th power. Number 32 involves another rule. The exponent is the second power. Everything inside the parentheses goes to second power, so that stuff inside the parentheses is times itself 2 times. So we get this. We get negative 5 q to the 4th r times negative 5 q to the 4th r. So the rule is that you would multiply that exponent, the 2, times everything inside each. But you can also just factor everything out like I did before. Negative 5, that's times q times q times q times q times r. And then again we have negative 5 times q times q times q times q times r. Okay, so now we got the negative 5 times negative 5 is 25. Negative times negative is positive. Let's see how many q's we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So q to the 8th power. How many r's we have? 2. So it's r to the 2nd power. That's pretty simple. So this problem here, in parentheses, negative 5q to the 4th r, since the whole parentheses to the 2nd power, you can multiply the 2 times the exponent of each one. So the negative 5 has a 1 exponent, so that gives us the negative 5, the whole negative 5, a 2 exponent, which means negative 5 times negative 5 is 25. The q to the 4th, you can multiply the 2 times the 4 and get 8, q to the 8th. And then r to the 1st power, multiply by 2, you get r to the 2nd power. That's the rule. But if you forget the rule, you can always just factor the whole thing out and get the answer quite simply without taking much longer than doing it the other way. Number 33, 8x to the negative 6th power. Now if you remember, negative 6th power makes the same thing into a fraction to that power. So for instance, 8 times x to the negative 6th power would be 8 over x to the 6th power. Remember, x to the negative 1 power equals 1 over x. So x to the negative 6th power would equal 1 over x to the 6th power. So you have 8x to the negative 6th power. You factor that and say, well, we've got 8, and that's times x to the negative 6th power, which is 8, times 1 over x to the 6th power. And if you put 8 over 1, Well, the 8 goes on top then. See? 8 over x to the 6th power. 20x to the 3rd divided by 5x to the 8th. Alright. So again, this one's the simplest done if it's factored out. So let's go 20 and we'll times x times x times x. And that's divided by 5 times 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. 8 x's. Okay, so we can divide the numbers, right? 5 into 20 is 4. Okay, so we've got 4 on top. Okay, let's now see about the x's. Well, we can cancel out x over x, x over x, x over x. So how many do we have left? 1, 2, 3, 4, 5. X to the 5th power. So our answer is 4 over x to the 5th power. Now you could follow the rule of when you're dividing variables with exponents, you subtract them. So we could do it that way too. We've got 20 x to the 3rd power over 5 x to the 8th power. And that gives us, well, 5 into 20, we've got the 4. And then we've got x to the 3rd power, and it's divided by x to the 8th power. So we subtract the two, we would have x to the 3rd power minus the 8th power, right? And that would give us 4x to the negative 5th power. However, we want to have positive exponents. So remember, x to the negative 5th power is the same as 1 over x to the 5th power. So we would have 4 over x to the 5th power. See, so we would get the same thing as we got right there.